Now, I hope, yes, I'm glad to see so many of you here this early hour on a Saturday morning, especially when I'm going to be talking about quantification and mean sherd weights, and so. But so I'm really glad I haven't put you off. But I hope that that over the course of the next 20 minutes or so, we might be able to see some interesting things that we can do with some of this data, which is quite things like mean sherd weights, average sherd weights are pretty well known in pottery studies, and I think we can use them to in a slightly more nuanced, to use that very that sort of buzzword way. Anyway, let's crack on. Right. Here's just a picture of. So I'll be coming to this site again. A grave with whole pots, but very fragmented, and that's important. So bear that in mind. Right. Well, as I said, most of us are pretty familiar with mean sherd weight. It's calculated as the weight divided by sherd count, and we can establish a mean sherd weight for our assemblage or groups within it, contexts or groups, contexts, or whatever. So let's just say we have actually this is a real total. We have an assemblage of almost 8,000 sherds, and it's 89 kilos, and do that calculation, and our average sherd weight is 11.3 grams. So that's all very nice and straightforward. And we can use the using mean sherd weight is a familiar way of looking at a useful way of looking at fragmentation of your assemblage, and that leads to we can use that information to look at questions about deposition patterns, waste management, zoning, activity areas, that sort of thing, based on some assumptions. For instance, that that the larger, fresher sherds will probably be closer to areas of use and perhaps initial discard. So they sort of focus really of settlement, rather, and much more fragmented pottery will perhaps a bit more sort of scattered. It's perhaps out in the fields where it's been a lot of process have been happening to it. It's been redeposited over and over again because and disturbed and broken up and separated out, if you like, through redeposition, agricultural processes, etc. So here's some mean sherd weights from by feature type from a site in just outside Aylesbury, Berryfields. This sort of the if you like, the hinterland of a Roman town, which I'll talk about in a minute. And so you can see some mean sherd weights from feature types. Road surface, there's a road surface at Akerman Street actually. Road surface, it's got some pretty chunky pottery, 22.8 grams. They've got pits, 17.8, etc. And you can see that that, as you'd expect, something like a wheel rut going on in the road, it would just have essentially just a few crumbs of pottery, and you can see that the corresponding mean sherd weight is 2.3. So very fragmented pottery from the wheel rut compared to, say, the pottery from pits, which are larger, and you can see that with 17.8 grams. Now we can do the same thing, and with the estimated vessel equivalent measure, or Eve. And I mean, and again, most of you will be familiar with this, but it's perhaps less widely applied than mean sherd weight. This is the completeness statistic that Clive Alton came up with, and it's explained in Alton Vincent Ires's Pottery and Archaeology, and of course the newer edition of that. And it's calculated as the number of vessels divided by the rim percentage. And it's the way, and for convenience, it's and certainly the way I do it is the number of vessels is the count of vessels is based on rims only. So we're basically looking at an average eve, really a mean eve. That's what we're looking at, and we can use the same that statistic to do a similar thing that we did for mean sherd weight. So now let's look at our feature types, and you can see this road surface. It was right at the top before. It's actually now you can see how that actually it's not quite as well preserved, if you like, as the mean sherd weight suggested. It's only the mean eve is only 3%, and whereas I should put this in order, I suppose, but it's but pits and ditches and actually post holes they're you can see that actually they're perhaps better preserved than the mean sherd weight initially suggested. 15%, that's the and 14% sort of the average eve. You can see this wheel rut. You can see that that's still very fragmented, as you can see that you know it's still it's 0%. So it just really was crumbs with no surviving rim. So so you can see that mean sherd weight doesn't tell you the whole picture, and so we get a slightly different picture by looking at mean eve, and that's very useful. I mean, this road surface, I should say, that's the reason why it was so the mean sherd weight was so heavy for the pottery from the road surface is because it comprised large storage jar sherds, which has perhaps been put into the road surface as repair, and these are body sherds. So that explains that. So let's look at another example. This is a site in Essex. It's on the A120 between Braintree and Stansted Airport. It's a site that was excavated in 2001 by Oxford Wessex Archaeology, a joint venture, and it was at the A120 upgrading. And one of the sites was along that route, along that linear route, was Little Canfield, or it's better known as Strood Hall, a Roman sort of farmstead, essentially. And you can see we had pretty much the whole plan of the settlement. And so this is the settlement itself, and there were some roundhouses here and things like that, a nice trackway. And then here is a cemetery, a little rural cemetery. And that was the slide right at the beginning on the title slide was a grave from this cemetery, and you can see that obviously it's a cemetery, a whole nice array of pots being placed in the graves, but you can see that after deposition they've suffered a bit, very cracked, and actually lifting some of these pots, they were lifted pretty much in very small bits, and have been, over time had been crushed. So of course that, so we're talking about whole pots, but yet if you do the mean sherd weight, of course, it's going to be very small. It's going to be very low, and of course this is an extreme example, of course, but it mean sherd weight in this case doesn't really reflect the sort of pottery that's going into those features. And if we can compare it with pits, these are first century burials, and so let's look at the first century pits and the pottery from there, and you can see that mean sherd weight, the pottery from the contemporary pits was pretty fragmented as well, and actually, it's not much different from the graves. You can see how fragmented the graves are. The pottery from the graves are, they're just 6%, 6 grams, and it's very similar to the pits. And if we just plot this on a simple bar chart like this, we find that the pits and the graves are interleaved. They're sort of, because pretty much the same sort of condition, quite fragmented. Now, sorry, frog in my throat. Right, I knew I should have done my warm-up exercises. Anyway, and so let's look at mean eaves. Now, of course, whole pots are going into the graves, so we expect a different picture to emerge, that actually the the condition, the sort of the mean Eve values will be much higher for graves compared with pits. And in fact, this is the case. Graves have a mean Eve of 0.36 Eves, or 36%, compared to just 3% for of the total rim circumference for pits. So you can see that we've now sort of separated out the using mean Eves. We've separated out those two features quite nicely. You can see, I mean, there is still some sort of interleaving, but actually a lot of the graves are skewed right to the end, and they have that, and you can see that, you know, we're dealing with pretty substantial vessels, because the rim circumference is still surviving. And of course, this is the beauty of Eves as a measure of quantification. It doesn't matter if you have a whole rim, 100% of a rim. It doesn't matter whether it's where you find it complete or find it in smashed to smithereens. It'll always be 1 Eve or 100%. So it's very useful. Now this is the, I mean, this is not hugely, you know, controversial. This is all, you know, I'm sure most of you are familiar with this sort of thing, but it's but what we don't often see is the two measures combined. And so this is what I've done, and the way we can combine it is simply by putting it on a scattergram. So here we go. Those two measures put on a single chart, and you can see how the graves are nicely, you know, they've really sort of separated out from the pits, and they occupy most of this space here. You can see how different they are at a glance from the pits, pottery from the pits, which are sort of right down the bottom here. So that's quite useful. We've got mean sherd weight on the x-axis and mean Eve on the y-axis, and we can that's a very nice sort of visual way of representing both measures to get a fuller picture of the condition of that pottery. Now, if we were to apply a sort of theoretical model to this, then this is the sort of thing we'd get. We've got this a mean sherd weight coming along here, and as we go along the x-axis, it becomes less fragmented. It's larger sherds, basically heavier sherds, and on the y-axis, mean Eve, as we go up, we get closer to 1 or 100%, and the pot's becoming more complete, if you like. So right in the corner here, closest to 0, we should have what we could term the poorest preserved pottery, the most fragmented pottery. And as we go up nearer the top right-hand corner, we should be seeing, this is where this will better preserve the larger sherds with more complete rims should be clustered. So we can use, this is quite a useful way of visualizing it. Now, of course, that's a sort of, you know, that's fine in theory, but in practice, of course, pottery is you know, the factors affecting the condition of the pottery are, of course, much more complex, and the picture isn't anywhere near usually so straightforward. So let's show that. I think I've got to move on. I think I've really sort of been spending too much on those earlier slides. Let's move on. This is Berryfields again. We've just shown you some of those. I've just shown you some of those the figures from Berryfields, and as you can see, it's a site on Aiken Street, road from Verulamium, essentially, right down to Cirencester via Bicester, Roman town at Alchester, I should say. And so this is what we're dealing with. And let's look at during post-excavation, the sites were my colleague Kate Brady, who did the stratigraphic work, divided the site into landscape groups, quite useful things that we could sort of make quite useful interpretative groups associated with the site. So we had groups associated with the road and enclosures off the road. There's a ladder settlement here, and so that was one landscape group, etc. So let's look at the mean sherd weight and mean eve for these landscape groups, and put them on the plot. And this is what we get. Now, over here we've got one. This is a G10. This is a pit and pond complex, and it had whole pots in it, or pretty near complete pots. And you can see that that this is where we expect it to be. It's coming towards the top right-hand corner. Just for in the interest of full disclosure, this pottery isn't from the site, but it's simply illustrating the sort of condition of the pottery that we got. That is over represented by the pottery in groups, in these landscape groups closer to the 0 mark. So this is more fragmented. So we've got more fragmented pottery here and better preserved pottery here. Now I mean, you could create sort of clusters, as many clusters as you like, but I sort of detected some vague groupings here. A group here of perhaps less well preserved pottery, and then 2 groups here of sort of middling, but actually pretty relatively well preserved pottery. Relatively high mean sherd weight, relatively high eaves, and where are those on our site? Well, the pottery that's if you like relatively well preserved by mean sherd weight and eaves are in landscape groups that are located alongside Aiken Street and within groups associated with this ladder settlement. Again, that goes along a minor road. The less well-preserved pottery, if you like, are in sort of field systems. So you can see that this all ties in nicely. That the better preserved pottery is perhaps is in areas where you'd expect a lot more activity alongside the roads and settlement to be focused. And the least preserved well preserved pottery is more in peripheral areas in the fields, and it's been perhaps been scattered through agricultural processes, etc. So that's pretty good. Now, pretty much hot off the press. Here's some. We've Oxford. Another joint venture, COPA, which is Cotswold Archaeology and Oxford Archaeology. We've been working along the HS2. This is HS2, and we've been working under the management of Fusion at the site of Fleet Marston, a Roman nucleated settlement, or in old money, small town. And Berryfields is actually here. So this bit here is this bit here. So Berryfields is actually part really of Fleet Marston small town. And so we're currently out there excavating now, but this is an earlier evaluation that we did, and well over 100 trenches went in. This is a line of Aiken Street, and we've got another road coming along here. So now this is so when I looked at the pottery for this evaluation, I again did a calculation of mean sherd weight and mean eaves for pottery by trench, and I plotted them on this graph, and you can see that the what really jumps out are these trenches here with relatively high mean sherd weight, but also the highest mean eave. And the right at the top here, they sort of really jump out here. And so where are those? So let's see where they are on our plan of Fleet Marston, and they're around here. So they're centered around the row of trenches around Aiken Street and trenches around this other road, which may tentatively identified as a road that leads to Dorchester-on-Thames. So again, it's a similar pattern to Berryfields, where the better preserved pottery is centered around the roads, where you're likely to get much more activity. So you know, as an evaluation, you know, this is, you know, you can say, you know, this is perhaps a way of then going to the you know, when you're thinking about next stage of excavation, you know, where you're likely to get good groups of pottery. That's not to say all the other pottery isn't worth studying. Of course it is, but it's you know, it sort of gives you a little bit of sort of a heads up really about where the settlement really is focused. Right. So let's get back to our theoretical model, and of course we can apply a little bit of statistics here. And if there was really relationship between mean Eve and mean sherd weight, in other words, as a perfect relationship, so as mean sherd weight increased, mean Eve increases in proportion. And if that was a perfect relationship, then doing regression analysis, we'd looking at the R² statistic, this line here represents R² equals 100%. So there's a perfect relationship between these two variables. Of course, as we've seen, it's not always the case, and very rarely the case, in fact. And so this is the Berryfields data again by landscape group, and so I've applied this regression analysis, and you can see that's 0.13. In other words, 13%. So 13% of the variation, if you like, is explained by the dependence of these two variables. Of course, that's very low. So actually, they're not really dependent at all. There's all sorts of other factors going on to decide to determine that sort of shapes this pattern. But we can improve it. We can start to remove some outliers. This is that road surface. So it's a big, heavy storage charge sherds. That's sort of skewing the graph a little bit. So let's take that out, and that immediately improves our statistic. We get is now 25%. It increased to 25%. Of so, if you like, of the coefficient of determination increased about 25%. So we get a little bit more. We get a little a better correlation, if you like, between mean Eves and mean sherd weight. Right. Finally, just to look at another site. This is Oxford Archaeology was at Winchester in between 2002 and 2007, and digging in this northwest corner of the site. Lankhills is up there somewhere. And one of the things as we get on late Roman towns is this late Roman dark earth horizons. And here you can see a section of this grey layer here is all dark earth. You can see it's just been piled on top of everything else. And actually brown here, you can see it's extensive. So this dark earth is environmental and finds analysis of the dark earth showed it wasn't cultivated soil. It was dumped, a lot of dumped deposits, occupation deposits, waste deposits, dumped in fairly quick succession, and actually a lot of pottery was preserved in there and in pretty good condition. So let's just look at the final graph showing showing the relationship between mean Eve and mean sherd weight by context within a single dark earth group, if you like. And here you go. You can see that the correlation is much better, 63%, 0.63. And this actually reflects the nature of the pottery. There's low residuality. It's not cultivated soil, so it's not bringing up lots of earlier pottery. It's it's pretty chunky. The pottery is pretty chunky. It's as I said, the soil, the environmental evidence suggested this sort of midden material was fairly homogeneous, and so what we're seeing is quite a coherent assemblage with a high level of integrity. so this is telling us something about the quality of the pottery that's coming out of this deposit, and as you can see, this is reflected in the higher R² statistic, the regression analysis. These, if you like, fragmentation plots, if I can call them that, are just a useful way of putting mean sherd weight and mean eaves together, and a good way of visualizing the data and essentially seeing what jumps out. And and therefore that can be used as a way of characterizing our deposition of our pottery. And using statistics like regression analysis, it's a useful way of measuring the integrity, the quality, the coherence, if you like, of an assemblage. And I think that's it.